I'm curious to see our ammeter working in a car. By measuring amperage, we can estimate off-engine battery runtime. Always good to know if you don't want to get stranded. They are all based on the same PCB, comprising stepper motor, microcontroller, functional network and power supply. Our hardware is versatile. The instrument features are programmed into the code, which we are loading accordingly. And there was quite some development work involved. Feel free to check out the previous videos. Instruments for temperature, fuel level and oil pressure can be realized using a single input. A second input turns it into a voltmeter. And together with a Hall sensor on this input, it's becoming an ammeter. Terminals for 12 volts in, 5 volts out, ground and the sensor are also serving for mounting. The Hall sensor is connected via 3 meters of cable to my test setup, reaching virtually any point in my car. I would love to use one, but unfortunately I don't have a 68 Firebird at hand. Instead, I'm using my Audi TT for testing. The sensor is clipped over the main power cable and is connected as explained. Our board is tolerating 9 to 25 volts and can be supplied from the onboard network. However, we are using two 7.5 volt batteries in series to be flexible with the test setup. 600 mAh will last almost 10 hours. Installing the Hall sensor is easy. Open the clip, put it over the cable, close the clip and you're ready to measure. In case the instrument is indicating the wrong current direction, simply turn the sensor around. To avoid the stupid mistake I made, definitely watch the following. Look at this. There are 3 different power rails connected to the positive pole. Certainly not all currents are flowing through the thick red cable I have chosen under the hood before. I'm only measuring a part of the currents. But there is another solution. Definitely all currents must flow through the ground cable connected to the battery. Fortunately, it is accessible inside the battery compartment in the trunk. If you want to make this kind of experiments, I have to warn you about car electrics. 12 volts are not your problem, but the 1000 amps the battery can deliver are. For instance, in case you're causing a short with your ring, it will start to glow within a fraction of a second and you will lose your finger. Don't bet the narrowed conductor rails serving as a fuse will help you in that case. In general, be very careful. As expected, the radio is drawing little power, maybe 2 amps, even though it's actually a media system with navigation, media server and all that stuff. A classic car's tube radio would probably draw 5 times more. After switching on the ignition, we are measuring around 15 amps. Actually, it's the engine electronics, daytime running lights, sensors and assistance systems. The additional amperage from the matrix LED lights is surprisingly low. I can hardly see the difference. It may be 2 amps additionally. But when I'm turning on the ventilation up to full, we are measuring about 30 amps in total. The seat heating indicator comes on, but the power consumption doesn't increase. Apparently, it won't turn on unless the engine is running. The same applies to the window heating. That's clever, because the latter would drain the battery in short time. The electric starter is drawing 80 amps, corresponding to 1100 watts. During a cold start, the current would be even greater due to the higher friction of the engine oil. When the engine is running, the battery charging is starting only after 1 or 2 seconds. The electronics is checking whether the battery voltage is below a certain level to decide whether to charge or not. In order to save fuel, it's trying to charge the battery preferably when the engine is in overrun. That seems to make sense. Now I'm switching all consumers on again. When the engine is running, the seat and window heating are actually working. As we can see, the generator's power when idling is more than enough to run all electrical consumers. The battery is even being charged. So with modern cars you don't have to worry about electricity and battery charging. But with classic cars you do. Whether old or new cars, the device provides interesting insights and could be helpful in finding faults in the electric system. Maybe I will design a standalone ammeter that can be used in any car for such tests. What do you think about this idea? Write me in the comments. Interesting thoughts about battery runtime will follow in a minute. PCBWay, the sponsor of this video, was helping us with the hardware. And this time we not only had PCBWay make the boards, but also the assembly. A great offer, because we couldn't have achieved this quality on our own. But there's much more to discover on the company's website. Just take a look. Take the easy way with PCBWay. Sitting in my car waiting, I was often wondering how long the battery would last without the engine running. I'm giving you some estimates for a typical battery size of 60 ampere hours. The consumption figures of the elements you can find on the internet. Depending on amperage and charge level the battery needs to maintain, it's about 1 day to less than an hour. Even when it's indicating it, my car doesn't switch on big electrical loads when the engine isn't running. I expect the battery to last 1 or 2 hours in the worst case, and about 15 hours with the media system only. However, in case car electric is not so clever, it could be drained in half an hour. Just as a side note, all electrical consumers together are consuming up to 1 liter fuel per 100 kilometers or up to half a liter per hour. Hoping you enjoyed our development videos. Our spare part instruments for classic cars are just around the corner. Please take note, Electronics Unmasked is funded mainly by donations, and no matter how big or small, any donation is welcome. You can find our PayPal link below the video. Now stay tuned and don't forget to support the channel. See you soon in the coming episodes.